If you are just joining us for this section of this morning's event, my name is Ashleigh O'Neill, and I'm the manager of the Arclabs Research and Innovation Centre in Waterford Institute of Technology. So we were established in 2005 and have been making ideas work since then in a very special entrepreneurial ecosystem, which is driven by our co-location with the TSSG, the Telecommunications Software and Systems Group. And you'll hear from a couple of members of TSSG later this morning, and earlier this morning we had Kevin Doolan from the TSSG. And through Arclabs we run a number of programs to support entrepreneurship. So we have the Enterprise Ireland New Frontiers program, but we also have the NDRC at Arclabs Regional Accelerator program, which is also supported by Enterprise Ireland. And we're currently recruiting at the moment for early stage digital technology companies. So we're really hoping that through this event, we have inspired some of you to come on board with us if you're at an early stage of your venture and would like to really see your venture accelerate and grow to global scale. Really, the NDRC at Arclabs is the place for you. So we have a couple of different elements to this morning's proceedings. So we have a number of different speakers for you, different case studies, and each presentation is going to be nice and short so that you can get a kind of a flavour of all of the different things that are happening in this space. So we heard about some of the wider funding that's available earlier, and you're going to hear some specific examples of that as we work through this morning. So first up, I would like to invite Hazel Williams to turn on her camera and microphone there. So Hazel is from the Precision Agriculture Centre of Excellence and TSSG. So she's going to give us an overview of PACE and the TSSG and the open calls that are available for funding for companies at the moment. So I'll pass it over to you, Hazel. Thank you.
Great. Thank you for the introduction, Ashleigh. I just might confirm with you, Ashleigh, actually, that you can see my screen.
I can see you. I can't see your screen. I'd say you need to...
Just bear with me just for 1 second. Sorry, my apologies.
No, this is the reality. It looks like something is happening now. All right, perfect. So once it goes, superb. That's perfect, Hazel. You're in business.
Great, thank you so much. So good morning, ladies and gentlemen. My name is Hazel Williams. I'm the Senior Strategic Business Partner here at TSSG. I'm also the Regional Cluster Lead for Ireland and the UK for SmartAgriHubs, which is a European project that I'll discuss during this presentation. And I'm also the site manager for Vista Milk, located at WIT. And again, I'll give you a description of Vista Milk as well. So part of the agenda for today is I'll go through a couple of EU projects that have open calls coming out and cascade funding. You'll see that I'll use different terms at different stages, but they mean the same thing. So for example, with SmartAgriHubs, I'll talk to you about digital innovation hubs. I'll talk to you about flagship innovation experiments, which are pilots within the project, and then the open calls that are coming out of SmartAgriHubs. I'm going to talk predominantly about SmartAgriHubs today because the open calls deadline is actually looming for the 3rd of June. I'll then also talk to you about Agrobo Food, the pilots and the open calls, Demeter, the demonstrators, and the open calls then coming through Demeter as well. So some of you would have seen this slide earlier on that was presented by Kevin Doolan, but just to give you a very quick overview on TSSG if you weren't actually on the earlier presentations. So we're a research institute hosted by WIT. We're under co-directorship at the moment. Kevin presented earlier, Sazi will present in a short while. We've got areas of expertise around communication networks, machine learning and AI, emerging communications, and pervasive environments and computing. What I wanted to draw your attention to is this particular diagram here. And I suppose this is what's most important about TSSG when it actually comes to the open calls and the cascade funding, because we're very used to bringing basic research into applied and then commercialization. And you'll see all of the mechanics of TSSG and WIT working together in order to achieve this through all of the projects that we're engaged on. So SmartAgriHubs is a €20 million project, and today I'm going to specifically talk to you around the digital innovation hubs and introduce you to 2, PACE and Vista Milk. I'll also talk to you about flagship innovation experiments, 2 of which are located in Ireland. The other 26 are online, and I would encourage you to take a look at the other 26 flagship innovation experiments. And then I'll introduce you to the open calls. Just to say that this project is quite a large scale project, 108 partners. And normally these particular projects have maybe about 60 to 80 partners. and it's managed through 9 regional clusters. So again, we're the regional cluster leads for Ireland and the UK, and we try to bring on all of the digital innovation hubs across Ireland and the UK into the SmartAgriHubs portal. And we also encourage competency centres to list themselves as well on the actual portal itself. So PACE was launched in Kilkenny of last year. It's the Precision Agricultural Centre of Excellence. It's hosted by TSSG, WIT and Kilkenny County Council. It was brought about to drive the digital transformation of Europe's agri-food sector. But most importantly, it was a gateway for SMEs, micro-enterprises and also multinationals to gain access to the best in class with regards to technologies and research. I suppose as well from PACE's perspective, we're all about kind of the culture of collaboration, where it's not just about the services that TSSG or WIT can provide to you, but more importantly, we can introduce you to people within the actual ecosystem itself. So what is a digital innovation hub? Just for those of you who've never heard of the term before, a digital innovation hub provides services, business, technology, and ecosystem. They have to provide all of these services to be considered a digital innovation hub. So Ashleigh is from Arclabs, the incubation centre located down in WIT, and PACE is also an incubation centre located in Kilkenny. The Accelerator programme that will be described later on through NDRC, so I won't go into too much detail on that. The technology end of it, it's about the support on scale up, the technical infrastructure, and more importantly, when it comes to open calls, the testing and validation, which we have a team within TSSG that undertake that. And the actual services then around the ecosystem, we see PACE sitting here as kind of the community building, the strategy development, the scouting and brokerage, that whole idea of the kind of the workshops, the seminars to distribute and disseminate knowledge and expertise and experience right across the ecosystem. There's also then skills and training and education that can be provided, and this can be provided through PACE. It can also be provided through WIT, but also other organisations such as the one that Ethan mentioned earlier on, NUIG with the Ag Innovation. There's also ACE down in Tralee IT as well. So it's really, really important to understand that all of these services can be provided, but they don't necessarily have to be provided by the same RPO. Competency centres then, and I'm just mentioning competency centres because again, some people online may be competency centres. A competency centre would provide one service or maybe an activity. So as an example, RICON down in WIT look at business models and business strategies, and they will be registered as a competency centre within the SmartAgriHubs portal. So PACE itself has the capability through the SmartAgriHubs project to identify existing technologies. So in the last year, we would have gone through our TTO office here in WIT. We would have written to all of the TTO offices across Ireland, and through the SmartAgriHubs portal, we did a lot of technology scouting to see what was already existing out there, what could be repurposed into the Agri-Tech sector. We then can evaluate those technologies and assess their suitability depending on the organisation that makes an approach to us. Because there's no point in constantly reinventing the wheel if there's something already out there on the market, and that's a really important thing to say. Our plan this year then was to showcase those technologies through a series of workshops. Unfortunately, because of COVID-19, we won't be able to undertake those, but we will be looking at webinars similar to this. We do a lot of one-to-one meetings where we engage with organisations. We talk to them about their needs, what they need to do, and who they can actually engage with. And this is the introduction part. We introduce them to the solution providers then. We support the companies to secure funding. That could be through open calls, Cascade funding, Enterprise Ireland funding, and we have through PACE done a funding roadmap of all of the funding opportunities across Ireland and the UK, and that's available through the TSSG website and the PACE link on that. I'll give you a link later on in my presentation, and PACE will also have their own website in the coming year as well. And then we promote companies to help them to secure the R&D funding. We also use organisations like Liz Galvin's presenting later on to help support the securing of these kinds of funding as well. And we leverage those type of consultancy companies in order to assist SMEs and multinationals as well. I would also say as well that there is a new Ag-Tech Ireland cluster that was developed by Terra Nutra. Pora Hennessy in Terra Nutra has developed this Ag-Tech Ireland cluster, which is bringing all of the SMEs and anybody who's interested in Agri-Tech together under one cluster. And PACE has worked very closely with Pora Hennessy on that as well. So just to give you an example of the funding rates and the application process then for open calls, it's really important to say that your TRL level of your product has to be at level 7. And I suppose just to note for people who don't know certain terms that I'm talking about today, once you actually get my presentation, there's URLs in all of my notes and different things so that you can get all the descriptions there. But a lot of these European projects have TRL levels 5 to 7. And with the open calls, they're looking for you to bring their product or platform or introduce your product into their platform and bring it from a TRL level 7 up to a TRL level 9. The typical funding rates is about 300,000 thereabouts. It differs from Enterprise Ireland funding in the sense that there's no match funding required, but they are very competitively won funds as well. The types of companies that are eligible: SMEs, less than 250 employees, and earnings of no more than 50 million. The member states have to be involved, and the consortium is 2 to 5 partners within the consortium. One of them has to be a technology provider and the other an end user. The duration of the project can vary, but normally about 18 months for a lot of the open call funding for the duration of your actual project. The application template, as Kevin mentioned earlier on, 10 to 15 pages. They're not hugely cumbersome. Some companies try to do the application themselves. Through PACE and TSSG, we can do the application for you. And then also, again, we would leverage consultancy companies like Liz in order to assist SMEs and other organizations to look at those particular templates and to complete the application as well. Just to say, of course, you always have somebody who breaks all of the rules, and SmartAgriHubs has broken all of these rules. But I'll tell you a little bit about their open calls coming down. So when you engage with PACE and TSSG, although PACE was only established last year, we do leverage the expertise that has already been established in TSSG, which is over 20 years experience. We're recognised both nationally and EU and also globally with the new director of SASI coming on board and with the research that he's undertaking at the moment as the research and ICT leaders. We have innovation and commercialisation expertise in-house. We have a dedicated agri-food team, which I'm involved with, both in PACE and TSSG as well. And we've got several projects with open calls. We've got over 14 million euros of funding to give out through these open calls. And again, sometimes the open calls, there could be open calls through Teagasc with regards to DIVA, where if you approach us, there could be open calls and other opportunities through other RPOs. It doesn't necessarily have to be TSSG. We work directly with farmers and farming organisations, and that's really important to say again, because it's really, really important that about the testing and validation of these particular products before they go to market. So normally when you engage with us, we do what's called an innovation sprint. We started this a couple of months ago and we've had great success with it. And what we do is we build out a technology roadmap for you. So we can, in doing the technology roadmap for you, we can align the funding opportunities with that, whether the funding opportunity is within Enterprise Ireland or whether there's an open call as well. And then we work through the requirements of that particular open call, or if it's funding through Enterprise Ireland as an example. We also spin in and spin out companies with the support of PACE in Kilkenny and also Arclabs in Waterford. So Vista Milk then is a completely different digital innovation hub within SmartAgriHubs. It's an SFI centre supported by DAFM, and it was brought about to address the unprecedented challenges that lie ahead in agri-food. And I suppose when that particular quote was written back in 2011, we had no idea of what was ahead of us with the pandemic in 2020. And now more than ever, we have to differentiate ourselves if we want to become global leaders in the agri-tech industry. So Vista Milk's vision was to become the agent of responsible growth for the Irish dairy and ag-tech industry by being world-class leaders in fundamental and translational research. I won't describe any of the research because Sazi will be describing that later on. What's really, really important to say is this whole idea of this collaboration. We've got over 40 industry partners involved with co-funded research underway. We've got over 100 researchers across 6 RPOs located in Ireland, and we're all involved in over 18 EU fund research collaborations. So again, whilst TSSG have the likes of Demeter, SmartAgriHubs and Agrobo Food as an example, there are other RPOs in Ireland that have other funding opportunities that we can identify for you as well. So across Ireland, the RPOs that are involved in Vista Milk, Teagasc are the lead partner. You've got DCU, UCC, NUIG Galway, sorry, UCD. Now that I'm naming them, I'm wondering, I'm probably going to miss somebody. WIT, Tyndall, ICBF, UCC, TSSG, and of course Insight as well. And as Patrick had said earlier on, it's about building partnerships to create kind of groundbreaking innovations that will make Ireland this global leader, and be kind of first in class all the time and really differentiate ourselves globally. Vista Milk is about building out sustainable competitiveness, building academic and industry relationships, societal challenges, and creating a new agri-tech industry that's populated with highly trained staff. So within SmartAgriHubs, there are 2 flagship innovation experiments. These are the pilots. Well, in actual fact, 28, but there's 2 within Ireland. This particular one, the Farm Sustainability Audit, is about robust ways of measuring the sustainability on farms, and particularly dairy farms. It's analysing water and electricity usage, the genetics and herd data, the agri-trading information, in the hope that it would have increased levels of milk production. The second flagship innovation experiment is called STREAM, and it's about the biodiversity on these particular farms. So this first diagram we would have all been familiar with over the years, measuring the biodiversity in this manual way, and then the inputs into the computer would have looked somewhere like this, whereas STREAM hopes to look like this in the future. We've got over 300 farms on the actual project, and those 300 farms are creating real data flows, real-time data flows, automated reports, and then TSSG are putting the machine learning to identify the habitats on top of that. The output then will be the sustainability tool for remote assessment and management of farmland habitats. So the open call then itself, there are 2 individual open calls within SmartAgriHubs. Again, just to note the closing date of the 3rd of June. They had €6 million to put against the open calls, and they devised this new open call called Respond, and it was to assist SMEs in the realization of digital innovations that were mitigating the effects of COVID-19. And also, this is where they've broken the rule, it's also available to digital innovation hubs, that the proposals must include 1 digital innovation hub. To note, TSSG, because we are involved in the particular project and we're partners, we cannot be the digital innovation hub within your proposal. But again, through the SmartAgriHubs portal and through PACE, we can point you in the right direction to find a digital innovation hub located in Ireland or elsewhere for you. It's important to note that you must be registered on the SmartAgriHubs website or portal in order to be able to apply. And they're looking for applications in kind of managing food transport, donating food, the mobilization of the actual workforce, forecasting regional food. The list is endless, and it's on the actual SmartAgriHubs website. The open calls then themselves will close on the 3rd of June, and they're hoping that you'll be readily available to start your project on the 1st of July and end by December 2020. There will be 2 other calls coming out called Restart and Expand. Restart to look at restarting the economy in the agri-tech and agri-food sector. So the actual portal itself, again, to note, you must register on it. All of the digital innovation hubs and competency centres are available on site across Europe. But it's really, really important to say that this portal will give you access into a network in Europe. There's a calendar of events, there's training available online, there's a forum where a private room for Ireland and the UK, so that people can talk amongst themselves if they decide to go after a particular open call or other funding. There's also lots of questions that are input on a daily basis. And then very quickly, over the last couple of projects, Agrobo Food were part of the Northwest European cluster, and the project itself is about building up a pan-European network of digital innovation hubs that will look at robotic concepts around the agri-food sector. The pilot in that particular project is about the autonomous greenhouse logistics of aerobotics and the long-term goal of building a robot that can detect, judge maturity, pick and handle fruits and vegetables in a greenhouse. The open calls in this are actually already open, and they're due to close on the 1st of September. There will be 2 innovation experiment open calls, and then there will be 1 industrial challenges, which is more pointed towards larger multinationals, whereas this is pointed more towards the SMEs. Demeter, that Kevin would have spoken about earlier on and would have given you some information on. The information that I want to give to you is about the pilots. There are 20 pilots across Europe, and I would encourage you to take a look at all of these particular pilots if you're thinking about your technology with regards to interoperability, because then you would meet a critical requirement for the Demeter project. The pilots themselves then, as Kevin quite rightly said, they're across differing sectors. The one that's located in Ireland is to do with livestock. Tyndall, Teagasc and TSSG are involved in that particular pilot. But again, take a look at all 20 pilots across Europe. The open call for Demeter will be launching in September 2020. And again, the average budget, 300k, a 10-page application, and we can assist you with that, or again, we can support you by putting you in touch with different consultancy companies that can assist you as well. So the current upcoming open calls, whether it's either through TSSG or other open calls that are available in Europe, are available on this particular URL. The funding roadmap that I described earlier on, that has all of the funding opportunities across Ireland and the UK, was put together by PACE, DAFM and the Irish Bioeconomy Foundation, and that's available online as well. And there are my contact details. And my apologies for covering everything so quickly, but please do email me or telephone me, and we can set up a meeting for you. Thank you.
Excellent, Hazel. Thank you so much. That it is a phenomenal amount of information to cover in the short time we've got today. So like that you mentioned that you have the hyperlinks to all of those calls and all of the different information through the presentation, and that will be distributed to the participants here. So like that, they can have a look through and maybe come back to you with questions. It's a lot to digest for sure, but so many opportunities.
There are, and I suppose just to say as well that I do have additional slides that are hidden on the presentation that go into it as well, so that when you do get the presentation, you'll see those slides as well. But thank you.
Thank you so much, Hazel. Thank you. Okay, so we have Liz from your digital village is going to speak to us about the services that she provides to companies as they navigate the EU funding landscape and really breaking down the complexities to make it accessible. So I'll invite you to turn on your camera there, Liz.
Okay, sorry, I went straight into the presentation. I'm suffering from Ken not getting his presentation now, so I went straight into it. Just one moment, sorry now.
That's perfect, Liz.
Okay.
Excellent. Lovely to see you. So now if you can try your screen share and let's see if it's going to work for us this time.
So screen sharing.
This is where we're learning all kinds of flexibility with this current environment that we're living in. So I can see your desktop now as opposed to a presentation.
Yeah, just like that. Now I'm pressing on it as well. Just wait a sec. I think it hopefully will come up.
I can see Agri-Tech
web now.
Not just yet. Oh, there we are. So I'd say once you go into, perfect. That's absolutely super. So take it away, Liz.
Okay, so good morning, everybody. Still morning, just about. So thank you, everybody, for the presentation so far and for this opportunity also to our hosts today, ASA, TSG. There's a lot of you involved in it today. So I just wanted to maybe break things down a little bit more for people who see all these funding opportunities and hear about all these different programs that are happening, and to maybe put a human face on it as well in terms of how there is help out there, and by a bit of networking, a bit of information searching, and using the ecosystem that we do have here in Ireland, that hopefully we can make things a bit easier for people and access those funding opportunities and keep up to date with policy. So just a bit of background on our business. So my name is Liz Gavin. I have worked for the bones of 20 years in Brussels for the European Commission, for one being a public-private partnership for aviation research. So always in FP7 or Horizon 2020. So very experienced on the other side of the table, I suppose, in giving out grants, writing work programs, writing calls for proposals, and decided to come back to Ireland back in 2016, and now I run my own business here where I have a team of proposal writers, and we try to look for opportunities and link up SMEs but also third level organisations with those funding opportunities. So there's a short spiel on our business. I suppose, having sat in Brussels, I saw how the system worked and how different companies, big or small, networked the system and were able to take advantage of the opportunities there. So I wanted to see how I could maybe pass on some of my knowledge and capacity to companies here to help them to access some of this funding. So we specialize in a few different areas, I suppose. We've had success in different areas. So clean tech, agri-tech, bioeconomy, aviation because of my previous life, and medtech because Ireland's very, very active in the medtech area. So we've been involved in quite a number of those as well. So our basic 2 lines of service are proposal writing, so proposal development, I'll talk about that in a second, and also project administration. So in my previous life, I would have headed up teams who would have taken in the financial claims on the different grants. So I know the rules, I suppose, well. I know what they're looking for when people are submitting their claims and how the whole system works from that point of view. So we're very happy to help projects who have been awarded as well on that side. So maybe just quickly to give an overview of what all this, when you are sitting down to write a funding application, what are the kind of elements that we would help you with. So it's important to know for any proposal that you are writing, what is the background today, in fairness, from different speakers. And here in our ecosystem in Ireland, we really do try to help each other and learn as much as we can if we're applying for things from people who know. Then the eligibility criteria, obviously, so some of these calls you need other member states involved. Sometimes you don't. It just depends on the call, especially for the Cascade funding, the eligibility criteria perhaps than in the Horizon 2020 or in the Future Horizon Europe calls. And then obviously the funding rate, is it co-funded, is it fully funded, depending on the project and depending on the program. So we'll identify all those ideas or those criteria for you and go through it and explain it in layman's language, basically. And then we'll talk to you about your idea, of course, how it can match or not the call. We've had cases where people would come and say, oh, I think this is ideal for me, and actually it isn't. And we'll tell them that from the beginning. But then we'll keep an eye on funding calls coming out and alert them when something more appropriate comes along. And then during the actual proposal development, you'll always be asked, obviously, for the objectives of your project, where the money is going to be spent. And then the big one for the EU is what impact is your project going to have, and you have to explain those really well. But part of our work is to help you to express that and give you some ideas and show you some examples of other impacts, and just to feed your ideas, because what we find a lot is people have great ideas but they haven't expressed them out, and you just need to verbally express it for us most of the time, and we will then try to get it down on paper. If you have background documents, of course we'll use those and your website and that, but we'll try and help you. And then the implementation of any proposal is around how you're actually going to spend the money, what's it going to be spent on, what are the concrete tasks you're going to work on. So I suppose our day-to-day is writing proposals and doing project administration. So we have the time to dedicate to writing it properly. We're not jumping like you are between your day-to-day life and all of the pressures on that to just keep your business running or keep your office running. So we are there to just do that. And we will keep an eye as well on the funding landscape in general. So we would have clients in our community who keep us kind of on their books to keep an eye on funding opportunities as well. We have good ideas around how to present what you're looking for and the kind of partners you need. And then we would be, as I said, experienced in financial implementation. So we would be able to advise you on your budget and how the implementation. I suppose a lot of this is about building your story, explaining why your solution is a good one, how we can find an opportunity to match it into, and that's where we come in. Just again to maybe repeat what others have said this morning, maybe a bit, but I really want to make this point, because when I was in Brussels, I can tell you that the networking and the ecosystem over there is very, very different to what we have here in Ireland. And what we have here in Ireland is very, very special. We have quite a tight community of people who want to help each other. And if they don't have the money for you, they definitely have a contact for you or a signpost. And I think everyone on the panel this morning, but everyone in the wider ecosystem would have that to say. And I have to say we're very lucky, because it doesn't work like that in every EU country. And it doesn't work like that even in Brussels itself. So do connect into the ecosystem, do use these kind of opportunities and look out for them going forward as well, because that's how you'll see Ken in the next presentation. One of the ways he managed to get into this was through networking, and just keep on banging on doors and trying to find out information to get through to the next stage. Social media is very active on this. Twitter, I mean, we're all the people here are on Twitter. We're tweeting as much as we can. We're trying to keep people up to date with various things that are happening, and in advance. You know, there's no point in finding these things out too late. Tell us your ideas, express your interest, put your hand up and tell us, and we'll try to help. Do keep it simple and try to benefit from the opportunities that are out there. That's all for me. I'll leave you with my closing slide. Thanks, Ashleigh.
Excellent stuff, Liz. Thank you so much. And like with the other presenters, you know, there's a lot of information here that our participants will be able to come back to after the webinar, when they've digested all of this wonderful support and all of the resources that are available to them. So thank you so much, Liz. And hopefully now, Ken, we should be able to get you going now. I'm going to share the slides from my screen, and then you can kind of just give me a little bit of now.
Thanks, Ashleigh, so much. I've been on enough quizzes on Zoom now. You think I know how to work it, but we'll get there. So thanks for helping with this.
Perfect.
You can go ahead. That's great.
So we'll go into slideshow. Yeah.
Okay.
And there we go.
Super. So hi everybody, and thanks for bearing with me. So Ken McGrath is my name. I'm the Managing Director of Ashleigh Environmental. So we are an innovation-led technology company operating in the bioeconomy, and of course agriculture is a significant part of that, and it's at the heart of it. So today I'll briefly get through some background on ourselves, our own journey through a number of the funding structures that you've outlined, and obviously we'll focus a little on DIVA and how Liz and Co have been of great assistance to us. So just about us, so we were established in 2015 as a spin-out, in fact, of Ashleigh Farms, which is based in Waterford. We developed a world-first microwave pretreatment solution for agri and non-agri side stream valorizations, and we call this BioWave. There's been over 8 years of R&D, both internationally and in Ireland, on the interactions of microwaves on agri-organic waste streams and others, and also the scale-up and design. Our first full-scale pilot plant has been in operation since 2018 in Waterford at Ashleigh Farms, and we've been able to demonstrate on the biogas side an improvement in yield of over 30%. The treatment technology itself has a wide applicability across a range of biorefinery solutions also, and these would include elements like biomass pretreatment and bio-based side streams, valorizations for higher value applications. Next slide, please. And if you just, Ashleigh, just want to press it like about 5 times just to go through these. That's perfect. So I'll rattle through here. There's one more as well. Thanks. So just briefly on the technology to give people an overview. So we use microwaves, which is electromagnetic energy in its principle, as a feedstock pretreatment, as I mentioned, for anaerobic digestion and for biorefinery applications. So the biogas yield increases that we've seen to date, as I've mentioned, over 30%. We've had enhanced CH4 or biomethane production as well, and also sterilization benefits. And this technology what microwaves do is they're very unique in terms of the way that they interact with materials, and they provide a very a feature which is called volumetric heating, which actually heats from the inside out. We don't transfer energy, heat necessarily into products, but the microwave itself generates heat at a molecular level, causing a superior cell wall disruption, which is critical for wanting to upgrade products and agri side streams and others. So our system is a modular design for offsite construction. We have a bespoke remote control and monitoring system as part of this, and this is obviously very important for us when we talk more about DIVA and how it has aligned with the themes in DIVA. And it's for integration on new and existing plants. So next slide, please. So our target sectors, just briefly here. In the dairy side, we have recently been very fortunate to be granted funding through Enterprise Ireland and the government's Disruptive Technology Innovation Funding. And I'll talk a little bit further about that in a further slide. We're also trialling on the municipal side with in the area of biosolids. We're working with a major UK water utility at the moment on that. We're also developing projects in the brewing, distilling and the meat processing sectors. Next slide, please. So just a little bit about our background, and I'm sorry that the formatting has gone a little bit sideways on this, but to give you a sense of, I suppose, our journey, we would have started over 10 years ago looking at it primarily actually from a farmer's point of view in terms of taking agricultural waste in the form of manures and looking at various ideas that we could do to transform it into higher value products. And in this case, we were looking at biogas. So we just got out there and started to interact effectively with the science community. So this is our experimental research phase. What we found through that was obviously the EU is a really great it's a great sandpit for being able to raise funds, innovation-led funds, where you can test ideas and work with high-class research organizations and other SMEs to develop technologies and principles around how you may use these technologies. So we were successful through the FP7 project that ran from 2012 to 2014, where we were a project partner on it, and that was for research to the benefit of SMEs. We also then because of the results were so good from that, we actually created our own company, and that's where Ashleigh Environmental was set up. And we were the coordinator on Horizon 2020 Fast Track to Innovation project, where we brought in other SMEs into our projects and also continued to work with those that we'd worked with in the past to build our industrial prototype. As part of this as well, we were able to utilize the DIVA fund through the great work and assistance that we had from Liz Gavin and her team in Euro Digital Village. And that actually provided a great stepping stone for us into our next phase, which is our industrial scale. And I'll talk a little bit more about the Disruptive Technologies Innovation Fund in the next slide. So overall, it's a long road. There is obviously quite a lot of risk involved, but there's fantastic support and obviously fantastic avenues where innovation funding can be raised throughout Europe and in Ireland as well. With great support in Ireland for this. So next slide, please. So the DIVA Objectives, obviously cascade funding and brought to our attention by Liz and Co. We made an application early, I would say probably around February time last year, and we started our project in June, so a very short application period and grant approval period. We worked closely with Teagasc, who are obviously the partner based in Ireland for the DIVA Fund, and fantastic to work with, really bought into what we were doing from day one. Clearly we, because it's a digital innovation fund, we had to demonstrate how its applicability to ourselves. And as I mentioned, as part of our system, we have a significant software element, which we've done some really nice and neat upgrades to as part of the project. And also we've changed the mechanical aspects and to improve the process itself. So working with Liz and Teagasc, being able to work through the call criteria, the costs, obviously the eligibility form. We would have had experience in the past through Horizon 2020, but every call is different, and you really have to be, you really need to study the criteria to see what's eligible and what's eligible. But this was a great fit for us, and again, it was a great stepping stone for us in the middle of last year onto our next funding round, which I'll talk about later. So we've worked with Your Digital Village since I guess the middle of 2018, and continue to do, and have found that the link that Liz and co in her team have across the various networks has been invaluable. Next slide, please. And so just to give you a demonstration of how DIVA was great for us in terms of a stepping stone. So we are part of a consortium that's one of 16 projects which was granted Disruptive Technologies Innovation Fund by the government last December. So we are one of, I think, only 2 projects that are in the renewable energy space. We're teaming up with NVP Energy, who have a unique and highly disruptive wastewater treatment solution, and NUIG, where much of the technology was developed. So this is a really symbiotic partnership between both the SMEs and the university. The problem here that we're going to address is in the dairy sector, so in the milk production sector, where a litre of milk needs at least, if not more than 3 litres of wastewater, or it produces rather. There's elements of that in terms of dairy fats that are high energy carriers, but very difficult to break down within normal anaerobic digestion and biogas processes. So we're working together to use our expertise in our microwave system to be able to break down these long chain fatty acids into short chain fatty acids for their conversion into renewable energy, and also further nutrients for higher value products. So this has been fantastic for us, for our company. It's allowed us to bring new staff on board, and it wouldn't have been possible without the support network that we've had, and being able to work through DIVA as well has been a great addition to us. Thank you.
That is super. Thank you so much, Ken. And yeah, sorry for the technical difficulty. I don't know why you weren't able to share your own slides like that. It's great to hear the experience directly from a company that has had such success and wish continued success with all of your projects and innovations. Any questions that participants have, if they can pop them into the chat, and we might come back to you if there's specific questions. Ken, if that's all right, are you going to be with us for a few more minutes?
No problem, sure. Thanks very much.
Excellent, thank you, Ken. So now, Sazi, I can invite you to turn on your video and your microphone. I am delighted to be passing you over now to Dr. Sasitharan Balasubramaniam, who is going to bring us through an overview of the emerging agri-technologies that TSSG are working on. So Sazi is the Director of Research in the Telecommunications Software and Systems Group. So we've heard from Gavin earlier, the Director of Innovation, and Hazel Williams earlier as well. So Sazi is going to give the insight into our emerging technologies in agri. So thank you so much, Sazi.
Thank you, Ashleigh. Can you see my slides okay?
Yep, I can see them there. That's perfect.
Thank you very much. So my name, as Ashleigh mentioned, is Sasi Balasubramaniam, and I'm the Director of Research, co-directing the TSSG with Kevin Doolin. So I'm currently the PI of Vista Milk, and what I'm actually going to be presenting today is some of the platform research that we're doing in Vista Milk, which is research that will hopefully create new solutions within, let's say, 5 to 10 years, targeting largely from the basic science. So this is going to be the outline of my short talk today. I'll start with a very, very quick introduction, and then I'll get into a new area called molecular communications that we're actually looking at in Vista Milk, concepts of what we call virtual digital cow, and how we can also use that for biocomputing as well for Agri-Tech. And lastly, I'll touch on very quickly on a new concept we call programmable ingredients. So we all know the motivation of what this, the whole idea of Agri-Tech really is basically to develop new solutions that we can actually target for food security and sustainability going forward into the future here. These are some figures that I got from, it's actually quite old figures from 2009. But it's actually forecasted that the food demand is going to rise by up to 70%. This is not only going to be due to the actual population increase, but also the actual effects of climate change itself. So what our vision here is to see how we can use new and future technologies from ICT, which we've seen tremendous amount of development over the last few years, with various different types of communication networks being spread out through various different land areas, even not only talking about core infrastructures of the base stations that can actually communicate signals down to your mobile phone, but even miniature devices that we can see implanted into the various parts of the environment, transmitting various different types of information over this communication network. So this diagram here, our aim here is to look at how we can get these communication systems to overlay on top of the agricultural infrastructure that we have, and to actually collect various different types of data from the different parts of the infrastructure, allowing us to do analysis to give us key insights into how we can actually improve productivity and efficiency. So one area that we're actually looking at in the TSSG at the moment is actually looking towards 6G. Many of you may actually already know about 4G, 5G. It's actually rolling out right now. But we're actually looking at new types of communication systems we believe will be deployed by the year 2030 and beyond. And one of that area is actually called molecular communications. So what exactly is molecular communications? When we talk of conventional communication systems, especially most of you would think of your mobile phones, which usually communicate using conventional electromagnetic waves. You can see there's a picture of a base station that's actually sending signals and various different types of other types of data down to your mobile phone. But as I mentioned earlier, it's not only just to your phone, but even miniature devices. And these communicate through these electromagnetic waves, which is pretty much all around us everywhere at different frequencies. Okay? But what if we actually want to communicate between, let's say, small devices, and especially if we have these miniature devices that could be not only implanted in the animal itself, but even deep within the actual soil. And they're actually miniature and very, very small in scale. So here's an example of an implantable device that was actually developed by a research group in Spain back in 2013. It's a miniature device. They implanted it right into a cell. So the scale is actually constructed out of components, and they were able to implant this into the cell to actually collect information of the pressure that's been applied on the actual cell itself. So you can see the dimensions of this is actually very small, comparable to pretty much just a few tens of micrometers in scale, right? So if we want to actually have these devices implanted to collect data from us, the big question here is that how do we allow them to actually communicate? Do we actually allow them to actually communicate through electromagnetic waves? The problem here is that when you miniaturize the actual antenna down to such a miniature scale, a lot of the signaling that we're talking about here is going to be very, very high frequency. And those frequencies will never, ever actually penetrate through tissue. So you can never, ever have these devices communicate with each other or even enable us to actually extract information out of them. So the whole idea here is that can we use the natural communication process that naturally occurs within animals or even within the actual human body itself, and that's actually using molecules. So can we allow these devices to be engineered so that they can interact with the cells, or some of them can even actually be biological in nature. We engineer them to actually produce information molecules, and they can transmit between the devices and hopefully to an external device and onto the actual internet itself. So that's the whole area of molecular communications, and you can actually see the definition in red there. The ability to actually create communication systems and networks that's made out of biological components and processes that are actually found in nature. So we have a lot of this communication existing within the animal itself or within the actual human body and at various different types of scales, whether it's just molecular signaling that actually occurs between cells in a tissue, all the way to different organs actually communicating with each other using hormones. So our question here is that, can we override on top of those communication systems so that we can transmit key information to implantable devices? So the long-term vision of this is that for 6G itself is that we're going to actually transform from what has happened between 1G to 5G. Up to now, we've only been talking about electromagnetic waves that has been transmitted between the actual infrastructure. But what we believe will happen into 6G is what we call a signal medium conversion. So you actually have electromagnetic waves transmitted from a base station, and then from the base station deep down into possibly the soil, up into the plants itself, or even into the animals, down to the molecule level, to actually understand how these small miniature devices are actually collecting information, so that we can now open up and widen the spectrum of information that we can actually collect from the animals itself. Excuse me, itself. So how can we actually apply this into the Agri-Tech scene? So our long-term vision is to see whether we can create a concept, what we call a virtual digital cow, which means that can we actually simulate the actual organs and interworkings of the actual animal itself, in particular the actual microbiome and the gut of the actual cow, because a lot of the diseases, believe it or not, actually starts within the bacteria that are actually within the microbiome itself. And as you're actually feeding different types of, say, for example, feed into it for different types of cows, you might want to actually understand how the actual microbiome is actually functioning itself. And in the event that they're actually sick, then you would actually then be applying certain types of antibiotic drugs into them. And you'd also want to maybe have a very deep insight into actually understand the effects of that will also have on the microbiome. So our big long-term vision is to see whether we can literally create a digital copy of the actual animal itself sitting within the actual data center, allowing us to actually simulate and understand a lot of the functions that's happening within the microbiome. So the way we want to actually do this, the way we want to actually do this is not only actually understanding and modeling at the cell level, where we actually look at individual cells within the actual cow itself, within the actual microbiome. It could be the tissue of the actual gut, and the bacteria is actually communicating and signaling between them, but even up all the way to how the actual tissues will actually communicate between tissues, and tissue will communicate, and even actually organ to organ communication. So you can have a very deep insight using this multi-scale communication all the way from molecular scale to the cellular scale, up to the tissue level itself. So for every small, even drug molecules that actually comes in, we can find out how it actually impacts at the tissue level, and even down to even at the cell level itself. How those cells will then react and respond and produce different types of molecules, whether they'll accept the drugs or whether they'll not accept the drugs, and what are the actual consequences from that. So what we're actually interested in Vista Milk is to do microbiome communications and using simulation modeling that we can do in the actual data center itself. So the way we look at it is that we take the data that is actually a lot of data that's out there, in particular microbiome data that involves how different bacterial populations are actually communicating with each other. We take that data and we reverse engineer that. And once we reverse engineer that, we try to find out which particular bacteria species are actually communicating. Can we identify the actual genetic circuits responsible for actually communicating those signals? Can we then simulate those pathways, and from there simulate how the bacteria are actually interacting with each other? So here actually shows an example of one of the works that we're actually trying to do. It's an animation for a population-based simulation of two populations of bacteria. We actually collected data from a population of bacteria within the yogurt itself. And you can actually see that as the bacteria are actually moving and signaling between each other, they'll actually change their response based on the color, because they dynamically change. So actually, when you actually change the feed, or even the, let's say, for example, drug molecules that you apply to them, they'll actually respond by producing different molecules as they're communicating with each other. So we can go deep down inside to cell level communication, and as well as the population level itself. So, so what we're also interested here is also how we can also engineer those cells, actually create specialized communication between them. And it's coming from an area called synthetic biology. What our intention here is to use software tools. Here's an example on the right there called the Cello programming language. You can actually enter very high level functions you would like the cells to do. The software will then produce and design these genetic circuits. You then actually plug them into the actual bacteria itself or any other type of cells, and then you can create new specialized functions from that. A lot of this has been applied to humans to actually treat various different types of diseases. We also believe it can also be applied to animals as well. And the way we want to do it is to actually develop biological computers. When we think of biological computers, the first thing that comes to our mind are actually silicon technology, right? Especially down to the single gate level. And you can see here 2 examples of an OR gate and an AND gate. So they'll take in different types of input, process those inputs, and then give an output, right? And then when you actually assemble all these different gates itself, you get a massive circuit, and these circuits are actually what you find in your processors you have in your phone or your laptops. And they're built out of silicon technology. Now, the question here is that, do we want to stick such type of a silicon technology, non-organic device into the actual animal itself? Number one, you have problems with biocompatibility. Number two, you have problems with powering itself. So if I want to have this type of computing so that I can compute whether there's different types of biomarkers or enzymes that indicate diseases, how do I do that without using computing technology? So what we've done is that we've come to look at how we can actually engineer bacteria that will react like as if it's a digital gate. So you can see here is a picture of a population of bacteria. And instead of electrical signals, input 1 and 2 coming in, we actually have molecule signals coming in, green and this blue. And the bacteria are actually engineered to actually compute those molecules. And then once it computes, it will produce a red molecule that actually comes out of it, right? And here's an example of a single AND gate that we created. So we did some experimental work with another research group in Waterford IT, PMBRC. You can see here's an example of a single AND gate. And if it's actually clear, it's basically either a 1, 0, 0, 0, or 0, 1 input. And if it's actually yellow, it's actually both input 1, 1 going in, and it's actually producing an output molecule coming out. So what we want to do, next step, is to see whether we can then hook these different gates up together into a circuit. And in other words, do different computing. You can see in this example here, you have 4 inputs coming in, and then it actually produces 1 output. And we can actually 3D print a pill, and then in each of these compartments, we actually put different bacteria that represent different gates. So you can actually have the communication between the population. It will be basically like communication between the gates, and it will be literally a virtual digital biocomputer, I should say. So what we want to do, is that 3D print, put this into a pill, and we've already started collaborating with SEAM Research Center in WIT. They're producing this polymer-based pill that will allow us to actually put this group of bacteria inside so that it will actually do the computing. And then what we want to do after that is to see whether we can develop what we call a bacterial molecular computing chip, where we can have different compartments, microfluidic compartments, and you put these different populations of bacteria in. It could be an AND gate, it could be a switch, and you put in different samples into those compartments, and those bacteria will actually sense and find out what's actually wrong with that particular sample. It could be any type of samples you can put in into all those different compartments, and you can hook this up to hopefully your mobile phone, so you can do diagnostic testing out on the field itself. So what next, and how far can we really go? And in particular, can we actually couple this with other ICT technologies going forward into the future? So what we think we can happen, our big, massive, grand vision of the future, is that once we can create this virtual cow that we can actually simulate within the actual data center, starting, say, for example, the microbiome that I mentioned earlier, we can then have this synthetic biology software tool that will allow us to actually engineer the actual cells itself. They can be nanosensors or synthetic sensors. We can plug them into the actual animal itself and see how it's actually functioning, collect that data, and simulate it and view it digitally through our data center itself. So many of you may have heard of what they call human on a chip. This was actually developed at Wyss Institute at Harvard, where you actually take different organs of a human body and you can actually put them all into an actual chip here. Here's an example of what you have: a brain, a liver, and you can even have other types of organs such as kidney. And you can actually have different pipes connecting between them, representing a circulatory system. So when you actually apply different drugs into one of the compartments, say for example, the liver, you can find out how that's actually producing molecules that might affect the brain or even other organs itself. We're actually involved in a future emerging technology proposal that's actually due in next week, looking at how we can create such type of a chip infrastructure that could allow us to develop new types of therapeutic molecules for COVID-19. But what we are interested to do is to see whether we can bring this technology to do future drug analysis for animals in the future. So what will happen is that between your virtual cow that actually sits in the data center, you'd actually have what we like to call a cow on a chip, having all the different types of the organs that are represented within the actual cow sitting on all this chip. You can test the drugs. If it doesn't work well, you fine tune it once again digitally in your data center, test it again on your cow on a chip. And once it's all satisfactory, it's working well, you then apply it onto the animal itself. So it'll save money of actually, number one, doing animal testing. Number two, it'll also give you a more precision view of how you actually want to apply these drugs to the actual animal itself. I'm coming to the last part of my presentation now. One of the things that we're also interested in Vista Milk is how we can actually personalize milk by actually manipulating or programming their ingredients. Many of you know that, when you walk into the actual supermarket itself, there's numerous different types of milk brands that's actually available, and they have different nutrient compositions. And the whole idea here is that so that it'll actually be able to tailor for the different types of people who have different types of allergies, right? But we actually have to go beyond that as well, because we all vary from one person to another. It depends not only on our physical composition, our genetic background, but even our daily activities, age, and also the amount of physical exertion that we actually do, right? So we will all process the different types of milk differently. So what we're trying to do is to try to create kind of like a virtual gut model that once again we can actually simulate within the actual computer system, observing how we can see how the digestive process is done and how those enzymes would then propagate through the circulatory system and spread to the different types of organs, right? So that we can personalize and say, okay, for me, because of my heart rate, my blood pressure, I should be taking this type of ingredients compared to someone else who might have a different composition. So the way we're actually doing it is starting from the actual digestion process within the actual gut. We're trying to create a computer model there, in particular focusing on how we can actually model the digestive process of milk, understands the enzymes that's actually being produced, the amino acids and the fatty acids that is actually being produced, and how those enzymes would then go into the circulatory system. We can actually model and see based on, we actually try to take a real circulatory system of a human being, and then observe how those molecules will actually move along the blood vessels up until the target tissue, the kidney or the heart, how those molecules will then go into those tissues and actually get absorbed. So by changing the actual variations and the composition of the nutrients, we can then personalize and say that, okay, for Sasi, you need a composition of A, B, and C as follow, as opposed to some other individual. And that brings me to the end of my presentation today. Thank you very much.
Thank you so much, Sasi. That was an absolute mine of information. And like that, I think there's a lot for us to think about within the themes that you have discussed there. A couple of questions came in on the Q&A, but we're a little bit short on time. So I wonder if you could maybe type in a response to those, that you'll see them in the bottom panel of the chat there, and then everyone will be able to see that. So thank you so much for that wonderful presentation.
No problem. Thank you very much. Thanks, Ashleigh.
My pleasure. Now get this up. So we should be able to see, I'll just change that around. So the final section of our webinar this morning is a very interesting discussion with David Hunt from Cainthus. So Angela Duffy, our venture lead from the NDRC, is going to be leading the conversation with David. And really, this is all part of our recruitment for the NDRC at Arclabs Accelerator program. So for any early stage digital technology companies, so like that, any ag tech companies that would like to scale and grow, we would love to see applications to the program. The closing date for applications is the 28th of June, so there is still a month to get an application in, and you can have a conversation with David Scanlon or Angela Duffy from the NDRC through their office hours mechanism. So that's all being done online at the moment. And the accelerator itself will be from the 24th of August to the 3rd of December. The accelerator is valued at €75,000, so €50,000 cash investment in your company. and then €25,000 in programme provision costs. So all details for that accelerator are on www.ndrc.ie. And I am delighted to welcome Angela Duffy from the NDRC and David Hunt from Cainthus. If you guys would like to share your or turn on your cameras and your microphones so that you'll be able to have your chat there. Do we have Angela as well?
I have sound, but I can't turn on my video. I think the host has control of me, so I leave it to whoever's hosting to.
Perfect. I think Deirdre has hosting, so I'll get Deirdre to activate your camera. And David, I can see that we have you. So just a huge welcome to both of you, and I'm very much looking forward to there we are. We have Angela now. Super stuff. So welcome. Thank you.
Thanks very much. And hi, David. How are you? Thanks very much for joining us here. So I suppose I've been working with probably quite a few digital startups. I'm working with people out of the Southeast for a number of years now. And, you know, I have seen a lot of good ag-tech businesses starting out of Ireland. And, you know, looking at where they can go in terms of the applicability globally. And I thought of David and his story. So, you know, we have different landscapes in terms of agriculture in different parts of the world. We're very much a grass-fed nation, as is New Zealand and parts of France, etc. But it is different in different parts of the world. And I think that global view might come from you, David. So you are a Mayo man, unfortunately. And, you know, you are now based out of the beautiful Cong, and I'm very jealous of that. So tell me a little bit about your background, because you've come from a farming background and a business background as well.
Yeah, well, perhaps not quite a farming background, but I started my career as a corporate banker, and my family business would be Comex McKinnon, which is Ireland's largest grain trading company, and I was managing director of that business for a number of years before I left to start what ultimately became Cainthus, which was in around 2014. And then the other sort of slightly odd one is that I'm also involved with a place in San Francisco called Singularity University, where I'm one of their main speakers on the interactions of technology and agriculture. And I principally talk about global agricultural systems and what they start to look like as we see more digitalization. And covering such topics as, so for example, if we start seeing a lot of cellular-based meat, what does that do on a global systematic basis, as opposed to looking at it in isolation?
So you've seen quite a few different things, and I think it was a trip to the US in the first place that sort of sent your mind thinking about the revolution in agriculture. And how did you come to, I suppose, computer vision and where you're at now? Maybe people aren't so familiar with Cainthus. You can give them a little bit of background on maybe the customer that you're targeting and the need that those customers have.
Yeah, so just to explain how I got into this, I was the managing director at Comex back in 2013. And while there, I basically saw that a whole lot of the global agricultural problems fundamentally stem back to a lack of empirically valid measures to the average farmer with which to make better decisions. Like, we didn't know what or where we needed to improve because we didn't have enough information to actually know to make a good decision. So I went to Singularity University for the first time in 2013, thinking that this was an unsolvable problem in my lifetime. And I got exposed to a lot of bleeding edge technologies at that point in time. And computer vision really caught my eye because I could see that imaging sensors were decreasing in cost and increasing in quality at exponential rate of improvement. And I could also see that the graphical processing units that you needed to process raw imagery, they were also improving in quality while decreasing in cost as an exponential rate. So the fundamental concept that became Cainthus was, hang on a minute, if you get cheap imaging sensors and cheap processors, and do what I now know was prohibitively expensive software development to turn them into universal measurement devices, you could actually create a system that would be affordable to the average farmer, that would enable them to improve their understanding of the environment within which they are operating and consequently make better decisions. So upon the realization of that, it was like, right, global agriculture is getting digitalized just like every other industry, and computer vision is probably going to be the most cost-effective way to universally apply this to agriculture. We initially started out in crops, and that was largely because my agricultural background was mostly crops rather than livestock. But one of the other company founders, Robin Johnston, his father, Jay Johnston, was one of North America's leading dairy nutritionists. So a lot of our understanding of dairy and livestock came from Robin and his father. And we focused on dairy principally because it had the best unit economics with which to apply technology to, and it also had very good adoption rates of technology. So after very many painful years of fumbling around, working out what was the best cost benefit and business model with which to make offerings to farmers, we are now selling at sort of large-scale commercial farm level computer vision system where a farmer installs cameras and a Connect Compute node in their barn. And that today, that will give them back information principally on feed bunk management, tells them how much feed is available to the animals, whether the push-ups are happening on time, whether the deliveries are happening on time, whether the bunk cleanouts are happening as scheduled, and alerting the farmers if any discrepancies or if there's any low feed. In September, we should be rolling out our animal behavioral module, which will be basically giving you a 24-hour time budget of what all of the animals are doing. So we'll be giving behavioral feedback information to the farmers. And the principal customer we're servicing is dairy farmers with a minimum of 2,000 cows in indoor environments.
So that's interesting. So I'm going to sum up all your wonderful language and say you're a big brother for the cows in an indoor situation. So that I thought was quite interesting. So when you look out there, is there really, because of a large need, and it was alluded to in the earlier presentations as well, you know, huge demand because of increasing population and increasing nutritional needs. Is there a change in the way that people are farming out there? We see it even in Ireland. I'm from a farm, small farm, and you know, my brother went to agricultural college, but we're always going to have a small farm unless we buy more or amalgamate. So how different is the situation here to what you're seeing and applying, and where you're applying some of this know-how?
It's actually funny, you can increasingly see quite a lot of Irish dairy farming starting to learn from that more sort of intensified scale operations that we're seeing in other parts of the world. And the amount of Irish people you meet working on those large scale global dairies is quite amusing. We do travel well. But effectively what you're dealing with, the global average milk yield is about 2,400 kilograms of milk per animal per year. The yield of an intensive dairy system in California is 10,500 liters, is 10,500 kilograms of milk per animal per year. And Ireland, I think, and feel free to correct me, someone on the line, I think is about 7,000 liters per animal per year or something like that. So effectively, in terms of like emissions and environmental footprint and profitability, the more efficient your production model is, the better all of those things are. So you have disproportionately less emissions and land use from a high yielding animal than you do from a lower yielding animal. And we have a blog on our company webpage at the moment where we basically worked out that if you got all dairy animals in global production performing at the same level that US dairy cows are performing at, you could reduce the global herd number from 268 million cows to 69 million cows, while still having the same volume of milk being produced. So technologies like ours, where we're looking at efficiency, where we're looking at feeding efficiency, and also validating the welfare that by analyzing the animal's behavior to validate welfare and all this sort of thing, we're basically trying to create a scenario where you can maximize cow productivity without sacrificing the animal's welfare, and making that a replicable model that could be applied to any country in the world. It's somewhat ambitious, but the numbers are quite impressive once you start digging into them.
So effectively watching and ensuring that feed is maybe as scheduled and nutrition is as planned, and if not, intervening. So does your system then provide data information and alerts to allow people to adjust, and how does that happen?
Correct, providing alerts and when things are happening on time, and making sure that if something goes wrong that the farmer knows about it immediately. And again, bringing that back to like sort of Irish operations, we're increasingly in Ireland, I'm starting to see cows are starting to move indoors a bit more than they used to be. And I've been to a number of Irish dairies where they're cutting the grass, delivering it to the cows, and then the cows are being milked on a voluntary basis by milking robots rather than being moved into parlor systems. So again, that's where you're sort of seeing smaller scale Irish farming beginning to adopt some of the things that we've seen at the larger scale dairies in places like California.
When you mention unit economics and the farmer then thinking about, you know, the cost received, the price received for milk, costs involved, how is something like this, I suppose, you know, benefiting or changing those unit economics? Do you provide that story to a farmer? So what was the analysis that you did, or what was the testing, I suppose, that you did of the system?
I will politely say we found that out the hard way. There was a point in time in Cainthus where we had done proof of concepts of a whole range of different things that we could offer the farmer. And the first, I have no problem saying at this point that the first commercial system we were out there selling was a bit of a disaster, because we were giving the farmer kind of a bit of everything on an individual animal. And that led to, like, the data was overwhelming. Some farmers valued some things, some farmers valued other things, and it was all expensive. So the initial commercial rollout we did in 2018 was not very good. So we basically said, right, we need to focus, we need to strip all of this back and focus on a single unit economic cost benefit argument that any farmer in our target dairy of 2,000 cow plus indoor operations can understand, make sense of, and see the value of. So when we started looking at all of the things that we could do, the feed bunk management aspects and the animal behavioral aspects probably the most sense to offer to farmers initially. So basically the feed bunk management works well on a unit economic basis, because two of the largest costs in any dairy at that scale are labor and feed. So if you can provide a digital tool that reduces labor usage while also increasing feed efficiency, then you've hit the two single biggest costs that the dairy has. So that was why, based on all of the various things we've done over the years, feed bunk management ended up being the thing that was the first sort of commercially scalable product that we've launched, that we're successfully installing and receiving revenue for.
So in my world, you know, working with the startups pretty early, and you know, the first piece is to really understand the customer. Many of them come from the background that they're trying to address a problem in. And I guess, you know, doing that customer discovery piece, how did you start early days? So we talked about in the beginning, you know, you learned about, I suppose, technology, you had some economic background. And then with the partner, Robin, working on what was important to the farmers, and where was the gap then between that and I suppose 2018 pushing something out, because fail fast and often can be a great path, and working in that way. I did that in medtech, so producing some prototype and pushing it out as well. So how can you compare or talk about what you did or didn't do, or what you'd recommend?
I call it a failure of ambition and a failure of focus. And by a failure of ambition, I mean we were wildly over ambitious in what we felt we could achieve with the resources and time available to us. So instead of focusing on creating one function that was commercially that a farmer would pay you for, we were trying to create the individual cow management system where we created all functions at the same time. Not a good idea. So
very common. Most people, tech-led in particular, would like to put everything in there, and they're afraid that it won't be good enough if they don't. But very often we see the same thing, so people are very forgiving out there, and they like to try things and prove, one or two things at a time. So that's very normal.
And focus, and as you say, feedback is huge on that. Like we're forever indebted to our earliest customer, who's a man called Steve Maddox over in California. Because principally he would tell us exactly what he felt about our offerings as they evolved. And we had a real point, there was a point about a year and a half ago where we had a real moment of realization when we said, Steve, what are you doing with all the alerts we give you? And he went, I'm ignoring them. And we were like, what? That's incredibly valuable information. Why are you ignoring them? And he was like, yeah, I know it's valuable, but I can't do anything about it. So I'm just ignoring it because if I can't do anything about it, I don't want to know about it. So that led to us making a major change where we said, right, from now on, it doesn't matter if the farmer tells you it is valuable in a focus group. If you're sending the farmer the information and you can see that the information is not causing the farmer to respond in a fashion that they have felt offered value to their operation, then you haven't helped them, you've annoyed them. So don't do that anymore. And then we also got in, Aidan Connolly joined as our company CEO from Alltech, and he did an incredible job in getting us to focus on just one thing. And we had what we called our one pen, one barn, one farm strategy, where we would get one thing working in one pen, then we get it working in one barn, then we get it working on one farm, and then we would decide whether it was a commercially scalable product or not. So listening to the farmer and observing their responses in conjunction with the verbal feedback they were giving us, coupled with getting extreme focus on commercial execution, were the main ways that we got from, what I suppose fundamentally started out as a research project to getting something that was commercially valuable to large-scale dairy farmers.
Yeah, and we hear that. So, we work a lot with the investors, and, particularly looking at business opportunities, and they do want to see the size of it. So it's something in terms of a market opportunity that can, go from Ireland to, as you say, California or Canada or anywhere. And that's the first thing an investor wants to see. But, also they want to see that you prove it in a full loop, that you can build something, you can test it, you can push it out there, you can get the feedback, and that you can then also have a business model that makes sense, that the customer wants it and they're willing to pay for you. And even if that loop is quite tight, you've proved all aspects of your business essentially, like you were just saying. And then you can expand it, you can repeat that with a different set of customers or in a different geography and so on. So with guidance, you mentioned Alltech and, the CEO coming in. So where are you at right now, I suppose, in terms of reaching customers in different parts of the world?
So we started doing installs. We obviously had to shut down a bit for COVID-19, but we started doing installs again a week or two ago over in California. So we're currently fully booked up until the end of June with commercially paid installs. So we're like, basically, if we had a larger install team, we'd be doing more right now. So yeah, we're very happy that, and it's one of the things that has been surprising at COVID-19. While it's caused us operational issues, obviously, as it has everyone, it's also demonstrated the increasing value of digital technologies to people through this crisis. Because I mean, anything that enables you to view things remotely and reduce the requirement for labor seems to have increased in value over that period. And we're certainly seeing that in the sales response to what we do. So yeah, we're very busy at the moment is the short answer.
And I guess for people on here who might be in a business or thinking about a business that they want to expand into ag tech, in terms of funding this, how did you go about it in the early stages? Was it self-funded? How did you because there's a capital cost with anything that's hardware, and most of the ag tech things that I see are hardware and software. And you mentioned the hardware was easy, and the software was the more difficult piece here. So maybe talk a little bit about that, and then also the funding behind it.
It's not easy. One of the reasons we're focusing computer vision on an indoor environment is because computer vision doesn't like variability. And so you've less environmental variability with computer vision, but getting like what the buzzword is edge AI processing happening in a remote environment with poor connectivity, that was not easy. So no, hardware is hard, as they say. So the software development was also very difficult, but to say one was harder than the other is probably not correct. And, we remain, as far as we're aware, the only computer vision company in global ag tech that has actually demonstrated that they can scalably execute installs on a commercial basis. So it's the fact that we can do that and no one else seems to be able to do it is a massive source of our current competitive advantage. But yeah, so in terms of getting all of that deployed and getting it funded and everything, we initially started, my brother and I were fortunate enough to make quite a bit of capital early in our careers. So we self-funded the business for the first couple of years. We did a seed funding round of a couple of $100,000 in 2015. Then we got our initial commercial scaling round where we were going from prototype to build a commercial product. We raised a couple of million doing that. And then once we had proved we could go from prototype to something that a farmer would commercially pay for, we then did a large scale finance round, which we ended up doing with Cargill. We had a bunch of venture offers when we did that as well, but we felt like ag tech's a little bit different from other industries in that reputation and trust and all that is very important in the sales process. So for us to get capital from Cargill, who could, one, provide us with validation simply by the act of them investing in us, and secondarily giving us access to a large amount of global cows and access to extremely knowledgeable dairy nutritionists and dairy scientists to help further improve our product, that was a lot more compelling than any venture offers that we could get. We've also taken a small amount of grant funding, but that would be very small relative to the amount of investment capital that we have raised or equity-based raise.
I think that's an important point as well. So, grant funding is very important. If you are continuing on, though, you may need larger amounts, and with investors, picking the right investor that first of all you gel with, and so the relationship is strong, but also can give you more than just the money, is really important. That is familiar with the area that you're in, has network and connections, has advice that's in depth. So anybody thinking about that, it's very important to do so. In terms of raising that money, how did you go about it? I mean, were there sort of pitch days? Are there any tips and tricks for people that might be putting their business forward, and areas that you felt the people investing in you wanted to see? So
I had an unfair advantage in that I spent a number of years as a corporate banker. So having been both sides of the finance desk, that was very helpful in how we sought to raise. So like one of my understandings is the best way for you to raise capital is your ability to network with people who are seeking to invest in capital. We never really did any pitch days or accelerators or anything like that. We basically, again, self-funded to the point where we could do an impressive proof of concept demo. And then we used that to seek people who were trying to invest in ag tech and network our way to them, and then pitch to them effectively. And I mean, I got introduced to a lot of people through my friends in Singularity University. I already had a network of technology people who I've collaborated with in San Francisco on some ARPA-E projects and other US government stuff. So leveraging contacts through them. And then I also had my own agricultural networks from operating with Comex McKinnon for a number of years. But ironically, when we first did our deal with Cargill actually reached out to us. We already had a number of term sheets for venture deals, and Cargill got in touch on our company webpage and say, hey, we've read about what you're doing. It's very interesting, and we'd like to be in touch with you. So I suppose it's one of those things where you can create serendipity by getting yourself out there and getting your story out there. And, you know, I was fortunate to be on the public speaking circuit a bit through mostly Singularity University, where I would be in front of audiences explaining to them why I believed this was the future of agriculture, why I believed it would be good for the farmer, the environment, and the consumer. And we got a lot of inbound traction through appearing in newspapers. You know, we've been in the New Yorker, we've been in the New York Times, we've been in Bloomberg. So getting in a lot of the international press, getting on international television, that led to a lot of inbound investment opportunity for us as well.
So it sounds like there was quite a bit of capital in the very beginning. So when you say yourself and your brother had invested and self-funded, can you give us an estimate on that? Because I think a lot of people may not have that, and they may not actually have the opportunity or the network. So placing yourself, you know, in Ireland and working off of, you know, a farm or in a rural setting here, networks like that may not exist, and you know, they wouldn't have exposure to all of those different types of people. Give us an idea of what baseline you have, because I think you might be coming off a different baseline maybe than others.
It was a couple of $100,000. And it's one of those things. So one of the things we don't talk about enough in entrepreneurial circles is that most of the successful global entrepreneurs, they either came from wealthy backgrounds or they made their money previously in their career. And the average age of a successful entrepreneur is 45. The media likes to depict youthful founders because they're great stories, but the reality is the average age of a successful founder is about 45, and they mostly come from wealthy backgrounds. If you
we'd see the same, actually. We'd see a lot of people that are coming and actually would have not maybe been successful necessarily, but you know, would have worked for a time and then for themselves want to do something. So it's very admirable to see people coming onto the program and stepping out from one place into maybe a tech world where they would have been, you know, working a different type of business. So you're absolutely right. I think even in Ireland, we're definitely looking at people in their 40s and that number's going up actually, which is very nice because these people have an old head rather than trying to put an old head on young shoulders. So it's much easier for us to work with them as well.
Yeah, but I would add that, you know, if you haven't made that personal capital already in your career that you can afford to squander in a foolhardy effort to create a technology company, grants are probably your best access to that. And the ability for you to work through the grant system to get to proof of concept, to enable yourself to be investable at a later point, that is a good pathway. The main trade-off you're making for doing that is time. Obviously, it costs time to do the grant process when you could be, you know, just working and deploying the capital on creating product rather than pursuing grants. And then on a secondary basis, depending on the nature of the grants and the timing and all that sort of thing, you can end up having quite an unhealthy capitalization table when it comes to do your financing round. So when you self-fund, you will always have a healthier cap table when the time comes to do a big round than if you've been seeking investment from the outset, or, and again, depending on the nature of the grants, depending on how you did your grants.
Yeah. So I think I see Ashleigh popping up, so I'm sensing we're running out of time. And just one quick question, I suppose, plenty of lessons learned in there, I guess, investing your own capital, but at the same time, you know, having to, you know, kind of iterate the product and push it out there, and, you know, realizing pieces of it weren't required. It's a very common story as well. But lots of things in terms of network that you discovered. Main lessons, some people on here, you know, pointers or lessons learned to help people here.
Oh, sorry, you'd like me to give a few pointers?
Yeah.
Well, sorry, the single most important, well, like, first of all, I always like to tell people that being an entrepreneur is an absolutely miserable existence, and it's way worse than having a job. And you should only actually do it if you've an itch that is the only way you can scratch it. You know, it's all encompassing. You've no free time. You're not making any money for a long point in time. So being prepared to go through that hardship, and that mental hardship in particular, that's something that's incredibly important. Secondarily, domain knowledge is key. Like, the best way you can get a competitive advantage is knowing the domain with which you want to solve a problem better than the other people who are attempting to solve that problem. And I always think as well that the best companies start with a problem. Like, my issue when I started Cainthus was, I can see all these inefficiencies in global agriculture that is causing us to use way more land than we should be using, that is fundamentally stemming back to a lack of available information. And that was the itch that I needed to scratch on a personal basis. But if you start with a cool piece of technology looking for a solution, and I mean, drones are probably the best worst examples of that at the moment. Drones are really cool. I've crashed loads of them. They're fun, but they're so much fun that a lot of people are trying to build businesses looking for problems with that cool technology, as opposed to and again with Cainthus, you know, here's this problem with agriculture where we need more digitalization. And, you know, we didn't get into computer vision because it was cool. We got into computer vision because it probably represented the most cost-effective way to get that information to a commercial farmer. So yeah, to boil it down, really make sure you're getting into it for the right reasons. And that reason should not be money, because 99% of startups fail and you're probably not going to make any. And the second one is that deep domain knowledge. And the third one is, know that you are approaching a problem that you want to solve, that you believe will have strong commercial value if you succeed. So those would be the main three ones I would advise people who are thinking about getting into AgTech.
Well, thanks a million. I think you're definitely right. If you're applying to Arclabs, an NDRC at Arclabs, we want to see that problem. We want to hear all about that, and that you have a great understanding of it. And of course, you know, if you have domain knowledge, industry knowledge, if you talk to enough potential customers, you should know the problem inside out and the landscape inside out. So absolutely agree with David. And it is a tough path, so we're here to support you. So thanks very much to David for his time, and thanks for the people who've organised here, PACE and ESA, and then Ashleigh and Arclabs helping out, and coming back in here to remind everybody of all the bits and pieces. I'll let you finish up.
It was such an amazing morning. You know, we've really, from 10 o'clock this morning, we've heard from so many wonderful speakers. David and Angela, that was such an amazing journey through the development of Cainthus and all of the different, I suppose, challenges you faced, David. And I think, as Angela alluded to there, certainly in the NDRC, they love founders that love the problem. And like that, if you're solving a significant problem, there's going to be a business in it, but there has to be that passion behind that business and that domain knowledge to feed it as well. So just those key dates again, the application process is open until the 28th of June. So there is another month that you have to put in your application. Until then, every Wednesday, there are virtual office hours that, again, if you go on to ndrc.ie, you'll be able to book a slot with Angela, who you've met this morning or this afternoon, and David Scanlon. So David and Angela are going to be the two venture leads. Thank you for the wave, Angela, that's super. So really, it's important to have that discussion about your application and give yourself the best opportunity to be able to pitch. So just to echo the thanks from the speakers this morning, from Angela herself, to the ASA, it's been such a pleasure to run this event with the ASA, with PACE, with the NDRC, and we've had an amazing variety of speakers from Karina Pearson Enterprise Ireland, Ethan Cleary from the IFA, Patrick Barrett from DAFM. So Seamus spoke for Seamus O'Mahony, President of the ASA. We had this in the second session. We had Hazel Williams from TSSG and PACE, Liz Gavin from Your Digital Village, Ken McGrath from Ashleigh Environmental, Balasubramaniam from TSSG, Angela and David from Cainthus. And just a huge thank you to Deirdre O'Gorman in TSSG, who did such a phenomenal job rallying us all together, and Barbara McGoldrick on the organising team from the ASA side. So you'll have the slides. We'll be working with the speakers to get the slides that we can to ye, and like that, do please get in touch if you have any questions at all around any of the materials that we covered today. So we've gone through an awful lot of information in the last 3 hours. So certainly if there are any additional questions, do please get in touch. Thank you so much, everybody, and I hope you all have a fantastic day.